$220 billion. That was the value of the global paint industry in 2025. Every year, the world produces around 50 billion liters of paint, enough to cover hundreds of millions of homes. But before it reaches the walls of your home, every pigment particle must be ground so finely that it becomes invisible to the naked eye, then pass through a series of strict manufacturing and quality control processes. Even the white color in most paints does not come from an ordinary white pigment, but from titanium dioxide, a mineral that produces the most widely used white pigment in the world. So what determines a paint's color, durability, and ability to stick to a surface? And what is really inside a can of paint? Whether it's house paint, automotive paint, or industrial coatings, every type of paint is made from 4 essential ingredients. Pigments provide the color. Binders hold the paint firmly to the surface. Solvents keep it in a liquid state for easy application. And additives improve everything from durability and drying time to moisture and mold resistance. The basic idea behind paint has existed for tens of thousands of years. Early humans crushed natural minerals like ochre to create some of the first pigments ever used. But modern paint is a completely different product. Thanks to industrial chemistry and large-scale manufacturing, today's paints are more durable, more consistent, and engineered for countless different applications. And it all begins with the most important ingredient of all: pigments. If binders are the backbone of paint, then pigments are its soul. For tens of thousands of years, humans could only get color from nature. Ochre provided yellow and reddish-brown tones. Iron oxide created warm earth colors, and finely ground charcoal produced black. These were some of the most common colors early humans could create. But some colors were worth more than gold. In ancient Rome, Tyrian purple was reserved for emperors because it had to be extracted from a rare species of sea snail. It was so expensive that only the most powerful people could afford it. Everything changed with the rise of modern chemistry, which made it possible to create colors that were brighter, more durable, and more consistent instead of relying entirely on natural materials. Among all these new pigments, one completely transformed the paint industry: titanium dioxide, the mineral we mentioned at the beginning of this video. It wasn't produced on an industrial scale until 1916, yet today it accounts for about 2/3 of all pigment used worldwide. Thanks to its extremely high refractive index, it scatters light more effectively than almost any other white pigment, giving modern paint its exceptional whiteness and hiding power. But inside the factory, pigments don't go straight into the mixing tanks. They first have to be dried, finely ground, and carefully controlled for particle size. If the particles aren't evenly distributed, the finished paint can end up with uneven color or poor hiding power. But color alone isn't enough. To stick firmly to a surface and last for years, paint needs another ingredient, a kind of invisible glue. That invisible glue is called the binder. Without it, the pigment particles would simply sit loosely on the surface and flake off as soon as the paint dried. The binder coats each pigment particle, locking them together into a durable film that firmly adheres to the surface. The type of binder and solvent determines whether a paint is water-based or oil-based. Water-based paints, such as acrylic and latex, use water as the solvent, allowing them to dry quickly and clean up easily. Oil-based paints use natural oils or alkyd resins, drying more slowly, but producing a harder, more durable, and glossier finish. What many people don't realize is that oil-based paint doesn't dry in the way most people think. Instead, it cures through a chemical reaction with oxygen in the air. This process can take weeks, and for very thick coatings, it may continue for years. However, oil-based paints also release significantly higher levels of volatile organic compounds, or VOCs. Combined with increasingly strict environmental regulations, this is one of the main reasons water-based paints are gradually overtaking oil-based paints in the global market. Inside massive mixing tanks, the binder is pumped in first to create the liquid base, allowing the pigments and other ingredients to disperse evenly. But at this stage, the mixture is still far too coarse to become the smooth, uniform paint we're familiar with. It must pass through the most important step in the entire manufacturing process. Welcome to the heart of the paint factory. After the initial mixing stage, the blend of pigments, binders, and solvents is still coarse. The pigment particles are clumped together and unevenly distributed. To fix this, the mixture is fed into a machine called a dissolver. A serrated mixing disc spins at a speed where its outer edge reaches about 20 meters per second, creating an extremely powerful vortex that breaks apart the clumps of pigment. But that's only the beginning. To achieve true fineness, the mixture is then sent through a bead mill, where millions of tiny ceramic beads continuously strike and rub against each pigment particle at high speed. This reduces the particle size to just 0.2 to 0.3 microns, about 300 times smaller than the diameter of a human hair. This is where the paint develops the smooth, uniform color you see in every can at the store. If the pigments aren't evenly dispersed, an entire batch of paint can end up with uneven color or poor hiding power. Once the required fineness is reached, the concentrated paint moves to the letdown stage. Here, the remaining resin, solvent, or water is added, bringing the solid's content to the exact formula required. Finally, the additives are introduced. Although they make up only a very small percentage of the formula, they determine whether the paint can resist mold, withstand UV exposure, and remain durable for years. These include defoamers, biocides, UV stabilizers, and thickeners. Before leaving the production line, the paint passes through a filtration system to remove any large particles or remaining impurities. Only after meeting the required fineness is it allowed to move on to quality control. After leaving the production line, the paint still isn't ready to leave the factory. Every batch must pass a series of rigorous quality tests. Technicians measure viscosity, gloss, hiding power, abrasion resistance, and UV resistance. Industrial coatings may also undergo salt spray testing to simulate the harsh conditions of a marine environment. These standards weren't always this strict. For decades, lead-based paint was widely used because it was durable and adhered well to surfaces. But after its harmful effects on children's nervous systems were confirmed, the United States banned lead-based paint for residential use in 1978, forcing the industry to develop safer formulations. Even color must prove itself under real-world conditions. The Golden Gate Bridge is a famous example. Its iconic international orange was originally nothing more than a rust prevention primer. But because it stood out so clearly in San Francisco's dense fog, it was chosen as the bridge's permanent color, and it has remained that way ever since. Only after passing every one of these tests is the paint finally packaged and ready to leave the factory. After all of those demanding processes, the paint is finally ready to leave the factory. But even the packaging stage is far more sophisticated than most people realize. For some premium paints, Especially oil-based products that are more prone to oxidation, filling takes place in a nitrogen atmosphere. The remaining air inside the can is replaced with nitrogen to help slow oxidation and extend the product's shelf life. The lid is then sealed automatically, and each can is assigned a barcode so every production batch can be accurately traced if a problem occurs. At many paint stores, automated tinting systems also allow customers to choose from thousands of different shades right at the counter in just a few minutes. This is a world away from how paint was handled just 2 centuries ago. Before the middle of the 19th century, artists stored their paint in animal bladders, piercing a small hole whenever they needed to squeeze some out. There was no reliable way to preserve paint for long periods. Everything changed in 1841 when American artist John Gough Rand invented the collapsible metal paint tube. From a leaking animal bladder to a paint can filled under an inert gas and tracked with a barcode. The evolution of paint packaging reflects the journey of the entire industry, from handcraft to precision manufacturing on an industrial scale. The next time you look at the walls of your home, remember that the thin layer of paint covering them is the result of tens of thousands of years of human ingenuity. From crushed ochre used in ancient caves to ceramic beads spinning at speeds of tens of meters per second inside modern factories. But the paint industry is now facing another turning point. Environmental regulations are becoming increasingly strict, and the global paint market is projected to grow to $280–330 billion between 2033 and 2035. The question is no longer just how to make paint that is durable and beautiful, but how to make it without compromising human health or the environment. Sometimes, the smallest and most overlooked things reveal the most about how humanity is changing its relationship with the world.